In number 3, we are given a block of 243 kilograms, and it is on a plane that is inclined at 34 degrees, and we've been given a coefficient of friction, and we expected to find out the acceleration. So the first thing I'm going to do is I'm going to determine the rate. Multiplying 243 by 9,8, I get 2381,4. I then break that up into its components. I have got a component perpendicular to the plane, 34 degrees goes in there, it's a 4. And I have a component that is parallel to the plane, and I can work those both out. The opposite side I work out using sine. I go sine 34 times by 2,381,4, and I get 1331,66 newtons. And on the other side over there, I'm going to say cos of 34 degrees times 2381,4. So I land up with 1974,29. Once I've done that, I know that the component down the plane is equivalent. That's the component of weight. And I know that the normal is equivalent to the component that is perpendicular. They then have given me a coefficient of friction, so best I try and work out the friction. Friction goes up the plane, and the frictional force is equal to the coefficient of friction times the normal, and the coefficient of friction is going to be 0,27, and the normal force is 1974,27. And when I work that out, I land up with 533,05. I then need to work out the resultant force. So resultant force is going to be equal to, on the plane, so I'm interested in that dimension, is going to be equal to 1331,66 times, subtract the frictional force, and I get a resultant force of 798,61. But I also know the resultant force is equal to the mass of this body multiplied by the acceleration of the system. I don't know the acceleration of the system, and I divide through and I get 3,29 meters per second squared. Here I'm told that an electric stroboscope is a flashing light, and emits 150 flashes per minute. So if it's 150 flashes in 1 minute, it then becomes 150 flashes in 60 seconds. So I can work out a frequency, divide by 150, divide by 150, and I get the time for one flash is equal to 0,4 seconds. So the first question is, what is the time interval between two successive flashes? So one flash, or between flashes, rather, it's like a ticker timer between dots, is going to be 0,4 seconds. It is used to pinpoint the exact position of an object falling freely from rest. So here's the position of the object. As you can see, it's getting further and further away from its starting position each time. The diagram shows the first 5 successive positions of the object pinpointed by the stroboscope. The next one is, what is the speed of the object at the time of the second flash? So I'm going to work out the distance from the first to the third and then work out the speed. So I'm going to say v from 1 to 3 is equal to 3,10 minus 0 over how many time spaces is that? 1 space, 2 spaces, 0,8 seconds, and I get 3,875 meters per second. Where is that true? At the second flash. What is the speed of the object at the time of the fourth flash? So this time I'm going to go from the third flash to the fifth flash, and I'm going to say 12,4 minus 3,1. I suppose this displacement here should have said meters. There isn't a unit over there. And then I divide through. Again, it's 2 spaces, so it's 0,8. And I get an answer of 11,625 meters per second. And where is that true? At the 4th point. So now if I'd like to determine the acceleration, acceleration is equal to final velocity minus initial velocity divided by the time between the second flash and the 4th flash, so it's 2 spaces again, and I land up with 9,688 meters per second squared, which makes sense because that would be pretty close to 9,8, the acceleration here on Earth. Determine the mass of object A and B from the graph. Now we've got an acceleration time and force graph, but let's just look at it. Force is equal to mass times acceleration, which means acceleration is equal to mass is equal to force divided by acceleration. That is equal to change in x over change in y. That is the inverse of the gradient. So if I'm going to work out the gradient, I'm going to have to flip it at the end. So first let's take point A, and from point A we are going to say change in y, 1, and I'm going to take the point 0 as well. So it's going to be change in y, 1 minus 0, over change in x, 200 minus 0, and I land up getting 1 over 200, which when I flip becomes 200 divided by 1, which is 200 kilograms. For point B, I'm going to take 2 minus 0 over 200 minus 0 is the gradient. Sorry, this is not equal. Therefore, if I'm flipping it, I get 200 divided by 2, and that is equal to 100 kilograms.